Dear chemistry colleagues, we are going to be discussing a number on chemical equilibrium, and this number involves a reaction between nitrogen monoxide and hydrogen gas, giving us nitrogen gas and water vapor gas. The question says a mixture of 0.1 moles of nitrogen monoxide, 0.05 moles of hydrogen, and 0.1 moles of water vapor is placed in a 1.0 liter vessel. The following equilibrium is established. So we have 2 moles nitrogen monoxide reacting with 2 moles of hydrogen gas in a reversible reaction, giving you nitrogen gas 1 mole and 2 moles of water vapor. If at equilibrium, we have the concentration of nitrogen monoxide at 0.062 molar, calculate the equilibrium concentrations of hydrogen, nitrogen, and water. Let's right away begin by writing chemical reaction once again. So we have 2 moles of nitrogen monoxide reacting with 2 moles of hydrogen gas in a reversible reaction, giving us nitrogen gas and 2 moles of water vapor. So initially, we have 0.1 moles of nitrogen monoxide. Then here we have 0.05. This one we have 0, and this we have 0.1. Now, if we assume that for the change, okay, I means the initial concentration, C means the change in concentration, and E is asking us the concentration at equilibrium, we shall say that if this is X, if the change in the concentration of what is at 0 is X, so this means that the change in here is going to be 2x, and then this one is going to be, since the ratio is 2 to 1 then 2, that means here we need a change to be minus 2x, because the hydrogen is reducing, hydrogen concentration is reducing in the forward reaction. Likewise, this is also going to be minus 2x, because this nitrogen monoxide is reducing in the forward reaction by minus 2. So at equilibrium, I'll have 0.1 minus 2x, then 0.05 minus 2x, I'll have x, and I'll have 0.1 plus 2x. Because here, currently, or initially I have 0.1, so if there is a change by 2x, then I'll have 0.1 plus 2x. Why is it a minus? Why is it a plus? Because here, this process is resulting into a product of water gas. So the reactants are the products are increasing, whereas reactants are reducing. Now, we already know that at equilibrium, the concentration of nitrogen monoxide is 0.062 moles per liter. So, can't we equate this to this? Because this same expression should equal to this for equilibrium to be established. So at equilibrium, 0.1 minus 2x will equal to 0.062, meaning that 2x will equal to 0.1 minus 0.062, and then x is going to be 0.1 minus 0.062, everything divided by 2, and then x is equal to 0.019 moles. That means that the moles of nitrogen present at equilibrium are equivalent to 0.019. And then to get the moles of hydrogen, in other words, the concentration of hydrogen is going to be 0.05 minus 2x. So I will have 0.05 minus 2 times 0.019. And this is 0.05 minus 0.038. And this is 0.012 molar. What is the concentration of nitrogen? This is X, which is 0.019 molar. Then what about for nitrogen? Okay, for water gas. So for water gas or water vapor, this will be 0.1 plus 2 times 0.019. This is equal to 0.138 molar. And that will be the answer to this problem. Now, in this example, we are given the following equation: hydrogen reacting with iodine to form 2 moles of hydrogen iodide. Calculate all concentrations when the concentration of hydrogen is equal to the concentration of iodine is equal to 0.2 molar initially, and Kc is equal to 64.0. Let's right away begin on the solution here. So we are told this is the equation for the reaction, and it's a reversible reaction. So meaning initially we are going to write our ICE. So initially we have how much of hydrogen? We have 0.2 and we have 0.2, and this is 0 because initially the two haven't reacted and there is 0 of the product. So what happens is that the reaction can only take place in the forward direction. And what is going to happen furthermore is that there is going to be a change in concentration. So if there is a change in concentration for this by minus, for example, x, and this as minus x, this is going to be a change by plus 2x. Yes, because they are in the ratio of iodine 1 mole and 1 mole of hydrogen, giving us 2 moles of hydrogen iodide. So we proceed at equilibrium, we get initial concentration, we add the change in concentration, and this is going to be giving us 0.2 minus x, 0.2 minus x for hydrogen and for iodine, and this is going to be 2x for hydrogen iodide. So the next step is to write the expression for Kc. Kc is equal to the concentration of the product raised by a power of the stoichiometric factor divided by the concentrations of the reactants, which is hydrogen and iodide, all raised to their stoichiometric exponent. So Kc here is provided as 64, giving us a 0. Okay, we have 2x squared divided by the concentration of hydrogen, which is 0.2 minus x raised to a power 1 times 0.2 minus x raised to a power 1. So the quickest way to deal with this is to take a square root. So we'll have square root both sides, and this is going to be 2x divided by 0.2 minus x. Yes, because if we had a square here and that's squared, then remember square root means power a half. So that and that are going, and then we will remain with 64 by square root. I will have 8. So this is equal to 2x divided by 0.2 minus x. So if I cross multiply, I'll have 1.6 here minus 8x, and this is equal to 2x. So 1.6 will equal to 10x because I move this 8x the other side. So here x will equal to 1.6 divided by 10, and this is the same as having 16 out of 100, and this is 0.16. That becomes the solution to this problem. Another one would have proceeded here. You square both sides, you square here, you expand this and form a quadratic equation. And then you'd find still that you have a value of x equivalent to 0.16. So we are going to be getting the concentration of hydrogen. The concentration of hydrogen at equilibrium is equal to 0.2 minus x, 0.2 minus x, which is 0.2 minus 0.16, and this is 0. So this gives us 0.04 molar. Likewise, we also have iodide. Iodide is 0.2 minus x, giving us 0.2 minus 0.16, giving us 0.04 molar. Then hydrogen iodide will be 2x. So we know the value of x, so this will be 2 times 0.16, and this gives us 0.32 molar. That marks the end of this calculation.